Hi everyone, welcome to School Coaching Point. Today we will discuss few important questions from the topic polynomial from class 9. Download the PDF from the link given in the description box. Subscribe and press the bell icon for more videos. So let's move to the topic polynomial. So first of all, we should know the general representation of a polynomial. That means how to represent a polynomial in general form we should know. So general representation an x to the power n minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus plus a to the a0. So this is known as what? General representation of a polynomial. So this is the general representation of a polynomial. So in this representation, so we have seen that how many terms? N plus 1 terms. That means number of terms is n plus 1 and a naught not equals to 0. So a naught not equals to 0. This is the important condition. And in this general representation, we can divide the number of terms and the coefficient. So an x to the power an minus 1 x to the power n minus 1 a naught are the terms of the given polynomial. So how to find out the terms? We have already learned in class 8. Similarly, the coefficient of the polynomial. So what are the coefficients? an minus 1, an minus 2 a naught are the coefficient of the given polynomial. So coefficient means the numbers or the part which is attached with the variable. So in this case an minus 1 a naught are known as the coefficient of the polynomial. So let's move to the next important point. So everyone should remember condition to become a polynomial. That means there should be some certain condition under which an expression becomes a polynomial. So what is the condition? An expression is considered as a polynomial. An expression is considered as a polynomial when power of the variable should be a whole number. The power of the variable should be a whole number. That means an expression becomes a polynomial when the power of the variables, so every power should be a whole number, then the given expression we consider as a polynomial. For example, x square plus 2x plus 1. So in this case, all the powers of the variable, so variable is x and powers are 2 and 1, and we know that 2 and 1 are whole numbers. So power of the given polynomial x square plus 2x plus 1 are whole numbers. It means x square plus 2x plus 1 represent a polynomial. So it is a polynomial. So taking one more example, x to the power 2 by 5 plus 5x to the power 3 by 2 plus 1. So this is a expression. So in this expression we have seen that the powers of the variable is not a whole number. So it's not a polynomial. So we have already discussed, because the power of the variable. So what are the powers? 2 by 5 and 3 by 2. Because the power of the variable, because the powers of the variable are not a whole number, because the powers are not a whole number. So since the powers are not a whole number, it means it does not represent a polynomial. So one more example, x plus 1 by x. So x plus 1 by x plus 1. So in this case, so x plus 1 by x, so 1 by x we can write x to the power minus 1 plus 1. So x to the power minus 1. So minus 1 is not a whole number. So power is not a whole number. X to the power minus 1, it means what? Minus 1 is not a whole number. So power is not a whole number. It means it does not represent a polynomial. So it is not a polynomial. So it is not a polynomial. So moves to the next important point, types of polynomial. So in this point we will discuss how many types are there, types of polynomial. So number 1, linear polynomial. Number 1, linear polynomial. So types of polynomial is very important. Linear polynomial. So linear polynomial, example, x plus 5 twice x plus y. These are known as the linear polynomial. Why linear polynomial? Because the powers of the variable is 1. Powers of the variable is 1. That's why it is known as linear polynomial. Number 2, quadratic polynomial. Number 2, quadratic polynomial. For example, x square plus twice x plus 1. So this is quadratic polynomial because the highest power of the variable is 2. So highest power of the variable is 2. That's why it is known as quadratic polynomial. So one more example, y square plus 3. So in this expression, y square plus 3, the highest power is 2. So highest power is 2. So number 3 in types of polynomial, cubic polynomial. Cubic polynomial. For example, x cube plus 5x square plus 3x plus 1. X cube plus 5x square plus 3x plus 1 is a cubic polynomial because the highest power is 3. The highest power of the variable is 3. That's why it is known as cubic polynomial. Number 4, constant polynomial. So constant polynomial. So number 4, constant polynomial. So any real number we consider as a constant polynomial. Any real numbers we consider as a constant polynomial. For example, 1, 2, -5, -6, -7. So all these are constant polynomial. So any real number is known as the constant polynomial. So number 5, zero polynomial. So zero polynomial. So how can we define zero polynomial? The constant polynomial 0 is known as zero polynomial. So the constant polynomial 0 is known as the zero polynomial. 0 is a real number, so which is also a constant polynomial. This constant polynomial 0 is known as the zero polynomial. So let's move to the next topic, degree of a polynomial. Degree of a polynomial. So this is very important, degree of a polynomial. So how can we define degree of a polynomial? The highest power of the variable, in a polynomial is known as degree of the polynomial. The highest power of the variable is known as what? Degree of the polynomial. The highest power is always represent the degree of the polynomial. So degree means, we have already discussed, the highest power of the variable. So degree means the highest power of a variable in the given polynomial. So for example, x to the power 5 plus 4x to the power 4 plus 5. So this is a polynomial and we have seen that the highest power is 5. What is the highest power? 5. So highest power is 5. Therefore, degree of the polynomial should be 5. Degree of the polynomial is 5. So let us take one more example. X cube plus 3x square plus x plus 1. So in this case, what is the highest power? 3 is the highest power. Highest power is 3. Therefore, degree of the polynomial is equals to 3. So next important point, degree of a constant polynomial. Degree of a constant polynomial is 0. So degree of a constant polynomial is 0. For example, 5 is a constant polynomial. We have already discussed. Any real number we consider as a constant polynomial. And this constant polynomial, the degree should be 0. Because 5 we can write as 5 into x to the power 0. We know that x to the power 0 means what? 1. When the power is 0, it should be equals to 1. So 5 is equals to 5 into x to the power 0. So what is the highest power of the variable? 0. Highest power is 0. Therefore, the degree is also 0. So, degree of a constant polynomial is equals to 0. So, don't confuse it x to the power 0, because we know that anything to the power 0 is equals to 1. So, 5 into x to the power 0 means 5. So, let's move to the exercise 2.1. We will discuss today exercise 2.1 and 2.2. So, in 2.1, verify which are the polynomial in one variable and which are not. So, in Roman number 1, 4x square minus 3x plus 7. So, this is a polynomial. We need to check. In this case, all the variables are whole numbers. So, power of the variable are whole number, because the power of x, what are the powers? 2 and 1, and 2 and 1 are whole numbers. So, power of the variable are whole numbers. Therefore, it is a polynomial. Therefore, it is a polynomial, because the power of the variable is 1, and this is also a polynomial in one variable, because it has only one variable, which is x. X is the only variable, so it is represent a polynomial in one variable. Roman number 2, 3 into root 2, 3 into root t plus root t into 2. So, in this case, root t means t to the power 1 by 2 plus t to the power 1 by 2 into 2. So, in this case, variable is t, but the power of the variable is not a whole number, because 1 by 2 is not a whole number. So, powers are not a whole number. Powers are not a whole number. So, if powers are not a whole numbers, therefore, it is not a polynomial. So, it is not a polynomial. So, next, Roman 3. So, Roman 3 we have already discussed. So, Roman number 3, y plus 2 by y plus 2 by y. So, 2 by y means 2 into y to the power 1, 2 into y to the power minus 1. So, minus 1 is not a whole number. It means what? It does not represent a polynomial. So, 2 by y means 2 into y to the power minus 1. So, minus 1 is not a whole number. So, it is not a polynomial. Number 4, x to the power 10, y to the power 3 plus t to the power 50. So, in this case, the powers are whole number. Powers are whole number. So, powers are whole number, it means it represents a polynomial. But how many variables? There are 3 variables, x, y, t. There are 3 variables, x, y, 3. So, it does not represent a polynomial in one variable. So, it is not a polynomial in one variable. So, it is a polynomial, but in 3 variables, not in one variable, because it has 3 variables, x, y and t. So, moves to the next question. Find the coefficient of x square. So, we have to find out the coefficient of x square. So, question number 1, 2 plus x square plus x. So, in this case, what is the number attached with the variable x square? So, 1 into x square plus x. So, 1 is multiplied with x square. So, coefficient should be 1. Coefficient of x square means the number which is attached with x square. So, coefficient of x square is 1. Roman 2, x into twice x plus 1. So, x into twice x, 2x square plus x into 1, x. So, what is the coefficient? 2 is attached with x square. So, coefficient should be 2. 2 is attached with x square, so coefficient should be 2. So next question, find the degree. Find the degree of the given polynomial. So number 1, degree, find the degree of the given polynomial. So degree means we have already learned the highest power of the variable in the polynomial. So degree means the highest power of the variable. So what is the polynomial? Roman number 1, 7x cube plus 4x square plus 1. So what is the highest power of the variable in the given polynomial is 3. 3 is the highest power. So since 3 is the highest power, therefore degree of the polynomial should be 3. So degree of the polynomial should be 3. Since the highest power is 3. Roman number 2, x plus 1. So this is a linear polynomial, and what is the highest power of x is 1. So highest power of the variable, highest power is equals to 1. Therefore degree is also 1. So number 3, 7. 7 is a constant polynomial. We have already discussed any real number we consider as a constant polynomial. So 7 is a real number. 7 we consider as a constant polynomial. So degree of a constant polynomial is 0. We have already discussed. Because 7 we can write as 7 into x to the power 0, where x to the power 0 is 1. So degree is 0. So don't confuse with x to the power 0 is 1, because when the power is 0, the value should be equals to 1. So 7 equals to 7 into x to the power 0. So move to the next question, find the 0 of the polynomial. So 0 means we need to find the value of x. So in class 8 we have already discussed linear equation in one variable, finding the value of x. So zeros and values of x, these are same. So zeros means the values of x. So in this case polynomial Px equals to x plus 2 is a polynomial. So there are certain rule how to find out the 0. So for finding the 0, for finding the zeros, we need to equate the given polynomial equals to 0. That means we should write Px equals to 0. That means we should write the given polynomial equals to 0. So Px equals to 0. It implies, what is the value of Px? X plus 2 equals to 0. So implies x equals to, transposing to the right hand side, it is minus 2. Transposing 2 to the right hand side, minus 2. So the value of x is minus 2. So therefore the 0 is minus 2. So Px equals to 0. So x equals to minus 2. So 0 is minus 2. So let us take one more example. Find the zeros. So in this case Px is equals to, so given Px equals to 4x square plus 9x plus 2. So Px equals to 0. So 4x square plus 9x plus 2 equals to 0. So in this case we need to split the middle term. So 4 into 2, 8. Now factorize 8, 1 and 8. So that means this 9 we should write in terms of 1 and 8. So splitting of the middle term we have already learned in class 8. So 9x means 8x plus x plus 2 equals to 0. So 4x square and 8x, taking common 4x. So after taking common 4x, it's x plus 8. Sorry, x plus 2. Take one common, x plus 2 is equals to 0. So after that take common x plus 2, x plus 2. So x plus 2 taking common 4x plus 1. So this polynomial has two factors, x plus 2 and 4x plus 1. Therefore x plus 2 equal to 0 implies x equals to minus 2. 4x plus 1 equals to 0 implies 4x equals to minus 1 implies x equals to minus 1 by 4. So therefore the zeros are minus 2 and minus 1 by 4. So what we have done, repeat the steps again. Px equals to 0, 4x square plus 9x plus 2 equals to 0, split the middle term. So 9x we have to write in terms of 8x and x, 8x plus x equals to 9x. So 4x square plus 8x plus x plus 2 equals to 0. So taking common 4x, x plus 2 and 1 common, x plus 2. So x plus 2 is the common, remaining is 4x plus 1. So x equals to minus 2 and x equals to minus 1 by 4. Therefore the zeros are minus 2 and minus 1 by 4. So move to the next question, verification of zeros. Verification of zeros. That means in this case the polynomial is given and the 0 is given. So we need to verify whether the given value of x is 0 or not. So in this case polynomial is x minus 2 and the value of x is 3. So for verification, so this is very important point you should remember. For verification we should put the given value of x. For verification, we should put the given value of x. After putting the value of x, if we get 0, after putting the value of x, if we get 0, then the given value should be a, then the given value should be a 0 of the polynomial. So what is the meaning of the line? When we put the values of x in the given polynomial, if we get 0, that means the given value we consider as a 0 of the polynomial. So in this case the polynomial is px equals to x minus 2. So here px is x minus 2. So put the value x equals to 3. So p3 equals to 3 minus 2 is equals to 1. So which is not equals to 0. So we have already discussed, we need to put the value of x in the given polynomial. So here x equals to 3. So p3 equals to 1, which is not equals to 0. Hence x equals to 3 is not a 0 of the polynomial. So if it is a 0 of the polynomial, so after putting the value we must get 0. But when we put x equals to 3 in the given polynomial, we have seen the result is 1. So exactly in the Roman number 2 also, px is 3x minus 3. So x is 1, put the value x equals to 1 in the given polynomial. So 3 into 1 minus 3. So 3 minus 3 equals to 0. So here we have seen when we put the value x equals to 1 in the given polynomial, we get 0. That means x equals to 1 is the 0.